Bismillahirrahmanirrahim. Today we will revise the cerebral dominance. Anatomical examination of the two cerebral hemispheres shows that the cortical gyri and fissures are almost identical. Moreover, nervous pathways projecting to the cortex do so largely contralaterally and equally to identical cortical areas. In addition, the cerebral commissures, especially the corpus callosum and anterior commissure, provide a pathway for information that is received in one hemisphere to be transferred to the other. Nevertheless, certain nervous activity is predominantly performed by one of the two cerebral hemispheres. Perception of the language and speech are functional areas of the behavior that are controlled by the dominant hemispheres in most individuals. By contrast, spatial perception, recognition of faces, and music are interpreted by the non-dominant hemisphere. More than 90% of the adult population is right-handed and therefore is left hemisphere dominant. About 96% of the adult population is left hemisphere dominant for speech. In their work on human fetuses and neonates, Yakovlev and Relyakic have shown that more descending fibers in the left pyramid cross over the midline in the decussation than vice versa. This would suggest that the anterior horn cells on the right side of the spinal cord have a greater corticospinal innervations than those on the left side in most individuals, which might explain the dominance of the right hand. Other researches have shown that the speech areas of the adult cortex is larger on the left than on the right, whereas the two hemispheres of the newborn are believed to have equipotential capabilities. During childhood, one hemisphere slowly comes to the dominant the other, and only after the first decade does the dominance become fixed. This would explain why a 5-year-old child with damage to the dominant hemispheres can easily learn to become left-handed and speak well, whereas this is almost impossible to the adult.